The first two lessons in this next unit are going to be included in this video. So the first one is called fossils. So why do we even worry about fossils other than them being super cool? They're going to tell us when, where, and how an organism lived. So they're going to give us information about organisms from our past. So what are some conditions needed to even get a fossil? The first thing is it has the organism, which organisms, to pause here, organisms are any living plants or animals, or in this case, they were living at a certain time. So that plant or animal had to be buried very, very quickly. If there's, and typically we're going to see more animals, if they're on the surface and they stay on the surface, might not get a fossil. They have to be protected from scavengers, and this would be different types of animals. So over a lot of different years, it would be different types. But if you have animals who are digging in the ground and digging up these organisms that have died, you're not going to end up with fossils. And the last thing is you typically need hard parts. So you're going to need bones and teeth. So a jellyfish, probably not going to make a fossil because you don't have those hard parts, the bones or the teeth. So there are 6 types of preservation. Preservation means to preserve or to save or keep. So there are 6 types. I have 3 on this slide, 3 on the next. The first one is mineral replacement. So in mineral replacement, of course, the organisms have to die to make a fossil, and then they're buried, which we just talked about that. So once they're buried, this groundwater, so water from the ground, starts to seep in. And then minerals from the groundwater are going to replace the parts of the organism. We find that later, you're going to have the shape, which is the fossil. The next type is a carbon film. So you're going to have gases that may escape and they're going to leave behind carbon. And then that carbon can create a silhouette of the organisms, known as a fossil. And the last type is coal. We actually learned a little bit about coal when we were learning about the different types of rocks. So coal has to do with anything living or organic. So in this case, they're mainly focusing on dead plants. So when you have a lot of heat and pressure that's compressing those dead plants, coal is a way to preserve. The next 3 types of preservation, molds and cast go hand in hand. So a mold, again, when the organism dies, is buried. There's going to be holes in the rocks, and that's going to let air and water come in. That water is going to dissolve, and it's going to leave a cavity in the rock. Okay, that gives you room for the fossil. Then looking at the cast, once you have that cavity in the rock, there's going to be sediments that fill into that cavity, and then they harden to rock. So as you can see, mold and cast do go together. So the mold creates the cavity, where then as the sediment fills in, you get it hardened into a rock, which becomes your fossil. The last type is trace fossils. So this would be typically if you have animal footprints or animal tracks that have been preserved. And they give us a lot of good information about the animal's activities. What kind of things did they do when they were alive? Last thing here would be index fossils. So index fossils can be really, really helpful. So they're going to be remains of species that existed. They may have only lived for a short period of time, but they were geographically widespread. So they weren't just in one, like in the United States, they weren't just in one little state. They were really widespread. And then if you can use that information, you can find the age of surrounding rocks, which we're going to be talking about age coming up in the next several lessons. So we'll get more into that. But the index fossils help you do it. So ancient environments, fossils can give us a lot of information about environments from the past. So it can help too, and the fossils help us do this, prove changes in the environment. So this is a picture. These are all index fossils. We're going to get to the different areas coming up in one of our next lessons. And you can see the different periods here. And if you found these fossils, it would tell you what period or what era it came from. So our next lesson is relative age. So relative age is determining the age of one rock layer compared to another. So when we're talking a lot about this, we're talking about rock layers down into the earth. And then this one's going to be more of a comparing. So my little rocks here, the one saying, hey, how old are you? And instead of saying I'm 500 years old, that rock is saying older than you. So when we talk about relative, we're comparing. What's the relationship? How are they related to each other? That's relative age. So how do we do it? So again, this fitting right in with this unit, fossils can be used. So a principle that's often used is superposition. So superposition simply tells us, again, looking at rock layers, the one on the bottom is the oldest, the one on the top is the youngest. really makes a lot of sense. So in this picture here, which actually comes from Edgenuity, you'll see it if you haven't already. Down here at the bottom, these would be the oldest layers. Up here at the top, they'd be the youngest. So another thing to point out, I didn't define this word, but the word correlating does come up. So this is a fault line here. And we learned about faults and shifting with earthquakes and other lessons. But you'll see these kind of dashed lines and dashed lines. So these would be correlating layers because they're the same material, but the fault has shifted them. So I just wanted to throw that word in there. I didn't define it, but just in case you see that word. Unconformities. So unconformities would be missing layers of rock. Could have been caused by erosion, which is that wearing away. We've learned about erosion a lot. So there's two types of unconforming, two types of missing layers. So disconformity is pretty simple. It's just the gap in the rock layers. Nonconformity has one other piece to it. So in nonconformity, you're going to have igneous and metamorphic rocks in the lower levels, and layers of sediment have come on top. So if you look at the pictures, disconformity, you just kind of see that the gap in between in here, the orange and the purple, you see that line would be the gap. Whereas nonconformity, you have those igneous rocks here, and this would be metamorphic, and the green would be the sedimentary that came over top. So those are your first two lessons of this unit.